Hello everybody, our topic for today will be about amplitude. And first, we have to know amplitude. It's the maximum displacement done by the oscillating body away from its original position or from its rest position. That's called A. So, if we see here, we can find that the object moves from A to B to A and to C, then returns back to A. The simple pendulum, the oscillating body, makes the maximum displacement on the left side at point B and the maximum displacement on the right side at point C. The maximum displacement is called here amplitude, and we can find in the other graph that the displacement is from A, B, then from B to A, then AC, then CA. All of them is called amplitude. So the amplitude is the maximum displacement, and its measuring unit is meter or centimeter. But in our lesson, we will calculate it in centimeter, and you can focus on it. So here we can find that the maximum displacement away from rest position is called amplitude. It's called what? Amplitude. Another concept that's called complete oscillation. What do we mean by complete oscillation? When the pendulum moves back and forth. How can we calculate that? If you see here the pendulum that can move from A to B, then returns back to A, then moves to C, then returns back to A, all of them is called complete oscillation. So from A to B, then from B to A, then from A to C, then from C to A. That's called complete oscillation. And when it begins to repeat its movement again from A, it's said that the body made a complete oscillation. Complete oscillation will be written as the following: A to B, then A to C, then to A again. Also, you have to know that if we find the relation between displacement and time, and you notice here that's recorded by complete oscillation, we can move from A to B to C to A again. We can find that the complete oscillation contains 4 successive amplitudes. As you see here, if you move above toward 1, you can see that's called 1/4 oscillation, and if you complete to A, that's called half oscillation, and then to C, that's called 3/4 oscillation, till reaching A, that's called complete oscillation. So we can pass through the rest position to successive time to make one complete oscillation, and each one complete oscillation contains 4 amplitudes. You can notice that complete oscillation equal 4 amplitude, and the amplitude equal quarter complete oscillation. This is referred to the relation between the displacement and time taken from a simple harmonic motion of a simple pendulum. From the opposite, you can conclude that the complete oscillation includes 4 amplitudes. Exercise: in which graph the amplitude is larger, and how many complete oscillations do they exist between point X and Y represented on both graphs? You can find that the amplitude is related to the maximum displacement. In curve number 1, by increasing the displacement, the amplitude increases. So, in 1, the complete oscillation also you can find that they are less than the complete oscillation in curve 2. So, curve 1 contains maximum amplitude than curve 2, and curve 1 contains less complete oscillation than curve 2. If you want to find the complete oscillation, you can find that curve 1 contains 1, then 2, 3 from X to Y. From X to Y you have 3 complete oscillation, but from X till reaching the last of the end of the curve, you can find that they are 3.5. In the second curve, you can find that we have from X to Y only 1, 2, 3, 4. So curve 2 contains 4 complete oscillations. So amplitude of curve 1 is larger than curve amplitude number 2. And the number of complete oscillations between point X and Y are, in curve 1, 3 complete oscillations. And in curve 2, we have 4 complete oscillations. Another exercise, in the opposite figure, calculate the distance covered by the pendulum to make 3 complete oscillations. You can see here that the maximum displacement from A to B is 5 centimeters. That's called amplitude. So, the distance of one complete oscillation equals 4 times amplitude. 4 times 5 equals 20 centimeters. If you want to find the distance of 3 complete oscillations, it will be 3 times the distance of one complete oscillation. 3 times 20 equals 60 centimeters or 0.6 meters. Another concept that's called periodic time. Periodic time is the time that's required for making one complete oscillation. So, if you can see here, one complete oscillation will take 0.1 second. So the periodic time will be 0.1 second. So if you wanted to define the periodic time, it's the time taken by an oscillating body to make one complete oscillation. And its measuring unit is second. So if we have an explanation, when the oscillating body needs a time of 0.5 seconds to make one complete amplitude, so it will take 0.4 times 0.5 times 4 equal 2 seconds to make one complete oscillation, and this time is known as periodic time. And don't forget that the measuring unit of periodic time is second. Also, we will find another relation that the periodic time equals time in second over the number of complete oscillations made by this object in this time. Another concept that's called frequency. Frequency is the number of complete oscillations made by an oscillating body in 1 second. If you see here, 1 second is required to make 3 complete oscillations. As you see here, so frequency equals 3 oscillations per second. Oscillation per second will be equivalent to another unit that's called hertz. If you have an explanation, when a simple pendulum makes 50 oscillations in 10 seconds, so the number of complete oscillations made in 1 second is 50 over 10 equals 5 oscillations over second, or 5 hertz. So frequency is the number of complete oscillations over time in seconds. You have to remember that the value of the periodic time will be equal to that of the frequency when the number of complete oscillations which is made by the oscillating body equal to the time taken by it in 1 second. But you have to know that 1 minute equals 60 seconds. And in the following example, if the number of complete oscillations which is made by an oscillating body in 1 minute equals 60 complete oscillations, so you can find that the periodic time will be equal the time that's required to make one complete oscillation. So it will be 60 over 60 equal 1 second. And the frequency, the number of complete oscillations made by time. So it will equal 60 over 60, that's equal 1 hertz.